Following on from the previous video, we've seen this. So what this means is that if you have a function, let's say f of x here, and then you have another function, let's say g of x. Now, when you look at this function, if you differentiate it, it will give you, let's say, this function here. So this here is f prime of x here, okay? And then here you've got a function. If you differentiate this function, let's say it also gives you this. So this is also g prime of x. Now what this is saying is that if you have the same derivative here, then the two original functions, the two antiderivatives must be exactly the same, but only differ by a constant. So look at this example here. Now try to find the antiderivative of this. So press pause and have a go. Okay, so when you look at this, just I don't know how you can teach this. You just have to accept that when you try and differentiate this, look what happens when you try and differentiate this. Let's visualize this as this. Let's visualize it as this. So when you try and differentiate this, it will give you 2 sine x, because 2 sine x, so it's you using the chain rule here, and then times with the derivative of the bubble itself. So that will be cos of x. Okay, so when you try and differentiate this here, it will give you this. So now make the adjustment in order to get, well, we don't want this 2 here. So now make the adjustment to our original guess. So the adjustment should be this. So here the antiderivative of this would be this. But here's the thing, would be this. Hang on. But here's the thing. If you instead of guessing this, we could try and guess this, cos squared of x. We could try and guess this, but let's visualize it like this. Now, okay, let's guess. Let's make this as I guess. So now let's guess this, and then try and differentiate this. So when you differentiate it, it will give you 2 cos x, and then times with the derivative of this thing here, which will be minus sine of x. Okay, and then when you tidy this up, it will give you minus 2 cos x sine of x. Okay, so now looking at this here, we don't want this negative 2. So make the adjustment. If you make this adjustment here, so here we've got this here is one solution. Okay, and then here we've got another solution. So, but here we've got another solution here. Hang on. Here we've got another solution here, but then so here this here is one solution, and then this here is another solution. But then up here it's saying that the two must be exactly the same, but only differ by a constant. But why is it that here you've got this? The two must be exactly the same, but only differ by a constant. The thing is these two are all exactly the same, and they do differ by a constant. Because if you draw a graph of this and you draw a graph of this, it will give you this. You see, they are actually the exact same thing, but only differ by a constant. So if you get this, take away this, it will give you a constant. Or if you get this whole thing, take away this thing here, it will give you a constant. So strange as it may seem, the two are exactly the same, and they do differ by a constant. Okay.